Recording in
Good afternoon, everyone. So, welcome to the online event Leverage Technology to Design Energy Efficient Buildings. So, we are going to have short presentations by the speakers and then an open panel discussion. So, I would request all the audience members to please put your questions in the Q&A box so that our moderator would pick up the uh, important questions and she can put in front of our panelist. So starting on, I would like to first launch a quick poll, and I would request all our participants to please take part in this. I'm just launching it. So all of you might be able to see the poll. So you need to specify your professional background, whether you are an architect, civil engineer, energy consultant, mechanical engineer, student, or from the other field. So I request everyone please uh, take part in the poll. So this will help us in giving direction and give us the idea of the mixture of audience. So I will just close the poll in 5 seconds. 5, 4, 3, 2, 1. I'm ending the poll. I'm going to share the results. So we can see 54% are architects, 18% are civil engineers, 5% are energy consultant, 9% are mechanical engineer, 2% are student, and 12% are from the other professional background. So thank you for participating in the poll. So moving on, I would like to introduce our esteemed moderator. So today our moderator is Dr. Architect Namrita Kalsi. So as a part of her past assignment, she has been the additional general manager architecture in Delhi Metro Rail Corporation Limited. Earlier, she was chief architect at New Delhi Municipal Council. She worked in the transport sector as joint VM architecture at Delhi Metro and in industrial sector as senior architect, Delhi State Industrial and Infrastructure Development Corporation Limited. So over to you, Namrita ma'am. Now you can please proceed.
Farhad, can I share the screen?
Sure, ma'am. Let me just share it.
How to convert into PPT mode because my screen is not visible. Is there a command for that?
F5, F5.
F5. Okay. Thank you. Good afternoon, everybody. We are today covering leverage technology to design energy efficient buildings. And the event is organized by WinZero and Capricorn Technologies. So here I'm sharing the journey so far by Capricorn, which was formed by the merger of 4 companies, and it's evolving into evolving into RIV, and then further taking step forward to get it to Win Zero. Now, what is Win Zero? Before going to that, let's understand that Capricorn is India's leading design and construction management technology and solution provider for architecture, engineering, and construction. And their vision is to help customers unleash ideas to create a better world, and strategy, end-to-end strategy, 360-degree technology solutions to customer through product sales. They have 20,000 plus customers and more than 250-300 staff. At present, they are standing at the threshold of Win Zero, which is basically a partnership between US CAD, CADline, Capricorn, and A2K organization in Australia, which are going to leverage Win Zero technologies. So coming to today's subject, I just want to briefly tell that what is zero energy buildings, which are buildings with zero net energy consumption. Energy consumed by building is equal to energy produced through renewable resources over a period of time, and the building produces less greenhouse gases as compared to non-energy buildings. And why do we need to go to zero energy buildings? To address the energy crisis that the world is facing, to reduce energy consumption, reduce greenhouse gases, reduce fossil fuel dependence, and to protect our environment for the future generation and climate control. So here I would just like to share my 1984 experience when I had done my thesis on residential scheme powered by naturally renewable energy resources under the guidance of Professor Arvind Krishan. And the solution that had come up in my thesis was later also leveraged in PIDA building in Chandigarh. So this thesis looked more at, sustainable solutions like hot water supply, cooking, electricity through energy, as well as generating thermocycling currents. And as I see down the lane that these things are still relevant for rural sustainability in terms of solar cooking, biogas, evaporative cooling, solar water heater, and probably agriculture sustainability. But when it's come to urban outlook, the thing is a different story, because the energy requirement and energy spent in urban area is far larger. It takes a piece of cake. So some of the technologies which have to look as far as urban area is concerned is nanotechnology. Nanotechnology mainly consists of the processing of separation, consolidation, and deformation of material by one atom or molecule. At present, many of the tiles available in the industry are coated with nanomaterials, and we find it very good. But these can also be leveraged to upgrade the previous technologies by having multi-junction solar cells, quantum dot solar cells, nano paints, nano printables, as far as big battery or storage is concerned, coating with active material for energy density, and next generation lithium batteries, and then even converting bricks into energy generation. With this, I come to one of our speakers, architect Britta Knobel-Gupta, who was born in Stuttgart, Germany. And she will be sharing with us their experiences, because Britta pursued her architectural study in Constance, Germany, Lyon, France. She received a scholarship in 2004 to study MR and urbanization DRL from Architectural Association School of Architecture, London. In 2006, she joined Zaha Hadid Architects and was involved in a number of seminal projects as lead project architect, which achieved international acclaim. Abu Dhabi Performing Arts Center Board, Art Museum in Michigan, and Dubai Opera House. She is also a professor at various architectural schools in Britain and Germany. So I am unable to read the last line. Okay. Her design philosophy fuses sustainability and computational optimization to create smarter, more ecologically sound solutions, blurring the line between landscape and architecture and allowing nature to permeate within the build is a defining feature of a practice and can be reflected in her work. So with that, I would like to give the opportunity to Britta to share her industry experience, that how she's using sustainability and energy solutions in practical world.
Thank you so much, Ms. Kalsi. Thank you so much for the introduction. So shall I share? And thank you so much, Capricorn, for inviting me. Okay. So I would like to start with a project, which is a railway station, also because Ms. Kalsi is here, and I think it's a very good project to showcase what we are understanding under sustainability and what we are understanding under performance-driven architecture. That really the performance is driving the design, performance is driving architecture, and performance is guiding us through the design process. So I want to start with Qualia. So I want to start with Qualia railway station, where we are looking at sustainability in a very broad way. We are looking at reviving the heritage. We are looking, of course, also at locally sourced materials, but also adaptive reuse and connecting the city here. So this is the original station building, which was built in 1909 in stone. And it is not a heritage listed building, but for us it is a heritage building, and we had the choice to also demolish it, but because it is a heritage building and we wanted to really retain it, because of course it's more sustainable to renovate a building than to rebuild a building. So this is the actual building made out of stone, 1909. And later on, this is the hustle of a daily station in India. Later on the left, you see it was added some more wings to it, which was painted. And on the right, you see the actual platform in the current state. So out of an urban perspective, we have the railway disconnected the city, the historic city and the new city development. So here with the station building, we really had a chance to connect the city again, which we of course wanted to use this opportunity to join both sides of the city again. So this is the existing building in the middle, 1908 in stone, and then they added later on these two wings on both sides, left and right, in 1980s in brick and plaster, and they painted it. So for us, in terms of adaptive reuse, we decided to maintain the existing structure, reuse it, renovate it, and then flank it with the new departure and arrival terminal, which is a requirement from the Indian Railway to separate the flows from departure and arrival. So we have a very clear distinction, very visible terminal, departure and arrival. So it's very clear for passenger to know where to go. So the same logic as any airport has to really separate the flows. And then by adding these two terminal departures and arrival on both sides, we are flanking it and we are giving it more appreciation again to the existing structure in the middle. So out of a two-dimensional structural system, which we found in the existing station, these arches, which was the most prominent architectural element around in this project. So we were really trying to use this two-dimensional arch and developing it into a three-dimensional structural system. How we designed it with this structural system, we designed the departure and arrival terminal, and also the covering of the platform, which you see in the background of the existing structure. This is the structural system with, of course, because we cannot shut down a running station, the columns, of course, have an in situ foundation, but then the columns will be prefabricated, the truss systems, the slabs will be prefabricated, structural roof system will be prefabricated and built up as soon as possible with a running station in the background. So this is actually the view when you drop off, and we have a new plaza with some water elements, some green elements, and you see here on the left the departure terminal and the covering of the platforms in the background, which embraces this old station building. And on the right is the arrival terminal. So it's a three-dimensional three-dimensional structural system where we added these eyes into it with also a Charlie to get some natural lighting into the platforms, of course, also to reduce the energy. And it's also animating the space. We actually got the clue for this Charlie from these existing windows of the station. So from there, we took in a way the Charlie and added it into that terminal project. This is the extent of a railway project now, which the Indian Railway is doing a lot in India. So it's a whole master plan where we are adding, also in the surrounding, we're adding residential, commercial, mixed use, various different programs which they will sell or lease out. So and on the bottom, you see the new proposed station building. So partly this master plan will of course be conserved. Some green areas will be conserved. Some areas, the blue mark, will be redeveloped. And in this case, because we are retaining the station, we are retrofitting the station. So we also have a retrofitting element. So this green goes into sale and lease. So some public plaza, some green parks for residents and commercial lotting, surface parking. This is the new road network and the new drop-offs, and also the proposed interchange nodes for various other ways of transportation. The proposed road network, interchange nodes. Here you see again what I just mentioned, the various programs of commercial residents, mixed use, which we are adding into the master plan to make it also viable for the Indian Railway. The top view. We have a drop-off on the back side and on the front side. So we have two drop-offs when you come from any direction. You can use the closer drop-off, and from each drop-off, you can enter departure and arrival separately. So it's never blending together. It's always separated, these flows. This is the main ground floor drawing. So if I zoom in, you arrive in the departure, you buy your ticket, then you go up with the escalator staircase to the concourse level. And from there, you can wait for your train. You can have a snack, you can have a coffee. You wait for your train to come, and then you go down the steps or escalator, or for handicapped people, of course, there's a lift. So this is in a way the logic, the flow completely separated, arrival and departure is also very clearly visible from outside. And then on the, I will just show you the concourse level in a minute. So this is again the drop-off view, a view into the departure terminal. And on the right side, you see the arrival terminal. This is the departure. So you arrive, you buy a ticket, and then you go up to the concourse level where you can relax and wait for your train. And you see here, this Charlies give you some natural light. So here you see better, it's also animating the space because, of course, during the day it will move and it will animate the space, and it gives a very nice differentiation to the space. And you see in the drop-off here, in the drop back, the original station on the left. And a view down from the concourse level after you relaxed, when your train is approaching. Here you can go down with the staircase or the escalator into this large space. So what I just want to mention, of course, the platforms are not in a regular grid. So the structural system is in some parts longer, in some parts smaller. Let's say the left platform is closer, the right one. So it's a structural system which we develop and can be applied to these various platform depths. So this is the concourse level and the roof plan. So when you arrive in the concourse level, you have, of course, the possibility for waiting areas. You can have some refreshments, retail, and then there's some VIP lounges, some restaurants for, you make your journey a little bit more easy and relaxed. And then here on the left, you see this corridor. Anyway, this is in reality this connection which connects the old part of the city with the new part of the city. So this is this connection which we created as a possibility to reconnect the city. And existing station building will be used on the ground floor as a small museum, shopping arcades, and on the first floor here, as you can see, as a restaurant, where we are using these balconies, these existing balconies. And then when you arrive, it's the same logic. You arrive, you go up to the concourse level, you can wait for your next train, or maybe you just want to leave. Then you just go down, escalate on staircase, and you can go back to the drop-off and get picked up with your cab or your car or any bus or any way of transport. This is the view of the concourse level down into the platforms. So here you see the ticketed area as a non-ticketed in this purple and ticketed in orange. So yeah, of course, then after some point it is ticketed and the lobby is non-ticketed. This is some more fire escape, vertical transportation. So this is again the structural system, and you see here in the middle the framing plan where you see different grids. So because of the existing platforms, we have a different grid which the structural system can manage. And of course, we are proposing to do it in stages. So first the departure terminal, then the arrival terminal, and then the central area where the renovation will be going on and drop-off. So it's all prefabricated, so it will be quick to install, as quick as possible. And then we are proposing also on this roof, because it's a very large area and it's very ideal to put photovoltaic on the roof, of course. So there we are proposing photovoltaic cells to also make it a net zero, maybe even might be net positive. So this is the structural system. You see here 32, 25, 28, it varies depending on the platforms. This is a small movie. So this is, it was an international competition which we won. And this is actually the panel which we gave for submission of the, when we presented a project. So we have various elements besides the photovoltaic on the roof. We are proposing natural ventilation. We have a passive cooling. We have some misting. We are using water saving fixtures. And also, which is an interesting element, piezoelectricity on the plaza. These are some tiles which creates energy, an active slab. So you see, we have various elements to make it really a net zero project. This is the overview of the whole master plan. So then we would like to show you one more project, which is much smaller and also looks at sustainability in very global and very large eyes under a very large umbrella. So here we are looking on the climate, of course, responsiveness to the climate, also locally sourced materials. And here, which is very special, I think, is that we are nesting villas within the earth to use the earth cooling. We are reducing direct heat gain by doing that, and also using the wind movement to cool the spaces. So I want to just quickly run you through this. So we looked at, this is in Rajasthan, in Udaipur. So here we looked at local clues of local patterns. So we found this hexagonal inspired pattern in the Hava Mahal, which we used. And then this is actually the site. It has a little inclination. So we used this pattern as a base grid for the site, which helps us then design it. But underlying grid always helps us. So we are overlaying it, then we are nesting actually these little cottages, these little villas within the earth here. Additionally, it gives us very private and introverted courtyards. So you feel private in your own cottage, which is important. So nobody looks into it. You have your private space, which you can enjoy. On the left, we have the drop-off. There we have some buildings like a restaurant, all-day dining, reception area. Then we have a swimming pool. So then you walk over the central area, which also has some water elements to cool down, to use the evaporative cooling. And then on the right side, you see the villas nested in nature. So on the left, after you drop off, you also have a shading because it's extremely hot. Actually, the wind flows in this direction, so it also helps us. We channel the wind. It goes over the water bodies, and then it blows over the cottages. And by using these chalies, we're actually getting the wind inside the courtyards, which I'll show you in a second. So, of course, we are also using these chalies to shade the courtyard, or partially at least. This is the wind direction. So luckily, it just goes linear over the side. So we're using this wind direction. This is the wind direction. And we are using this, I'll just show you this in a diagram. This is the view of the entrance of the cottages. So we have these 9 cottages. Also, what is important for us is to look at the closed loop construction, whatever we use, whatever we get from the site. Here, the excavation, the mud, we're using to use as mud bricks. So this also, of course, is a very important point in sustainability. This is a close-up view of these nested, cocooned villas with a daybed. This is a close-up with a little pool and the shading. So this chali was quite important to us because it has 2 roles. It's really shading. And on the other point, it is letting the wind go in. Because of the inclination, it's enhancing the wind flow and bringing it inside in your cottage to reduce the heat gain, to cool it down a little bit more. So here you see what the actual flow is doing of air. We developed this with Kohli together. This is the view from the cottage out of your little cocoon. And this is just an overview image. And with this, I would like to thank you very much for inviting me. I'm very looking forward to your questions.
Thank you, Britta. We would like to save the Q&A for the, sorry. Thank you, Britta. We would like to save the Q&A for the session after
Sure.
our other
Yeah.
speaker speak, so that, you know, everybody can put across their, you know,
Sure.
questions together. So with this, we will come to the next speaker. Before that, that is Millie. Before that, just a sec. I would just like to remind my listeners, audiences, that some of the materials which we have thrown out into the history dustbin, but which needs to be, resurrected for a better sustainability is cork, coffee husk, newspaper wood, mycelium, alga, recycled diapers, cob, plastic bricks, polyurethane, plant-based foam, and seaweed. With this, we come to Millie Majumdar, who is the master in this direction and is currently the managing director of Green Building Certification Institute Private Limited India and senior vice president of USGBC. In her current role, she is responsible for technical adaptation and customization of the portfolio of rating systems or GBCI for Asia Pacific region. She is also responsible for customer coordination, education, training, developing market mechanism for adaptation of tools and rating system for the region. An architecture graduate and a building technology specialist, Miss Millie has more than 2 decades of experience in the field of energy and environment, with a focus on sustainable development of habitats. She has also worked tremendously in the sector of green building, climate resilient housing, city planning, and urban transport. She has led a team of professionals to develop a portfolio of green rating system for habitat that have been widely accepted in India. She has also enabled the development of a large portfolio of green jobs through training and skill enhancement. So now I will request Millie to switch on her camera so that we can have a first-hand look at her while she shares her experiences. So Millie, I would like you to say hello to the audiences.
Yes, hi. It's great to join the event.
Yeah, Millie, we are having a format in which we would like to share your experience firsthand regarding how technology can, promote sustainability of different projects of different scales. So that is an experience we want you to share with our audiences.
Yeah, so thank you very much. I can, though I was not prepared to make a PowerPoint, but I can pull up a couple of slides if it's required. So I think, of course, as we have heard from the earlier presentation, that any design that incorporates sustainability has to be pre-evaluated, before you implement it, that how it will work, what are the nuances around it, how to design, how it will perform. So technology and per se, technologies that helps us to preempt performance of any building or urban plan is very critical. So in this respect, I would like to commend, the efforts of Capricot and other technology providers who have enabled technology solutions in form of software, tools, and techniques that help architects to make these design decisions. Now, one of the critical aspects of a green building or an urban planning is when you move through the process, is to see all the elements that come together to give shape to that particular environment. For example, just to give an example, suppose if you are putting a building or a large urban plan in a particular place, you would like to study the climatology of that place to see, how the wind will flow, how the sun, solar directions will move around. And accordingly, you will place the building, you will do the site orientation. You would like to see how much energy, it will consume. And technology provides you with that kind of a tool that will help you to estimate. And nowadays, as we scale buildings to urban level, and there are multiple issues that we are talking about. For example, climate resilience is a very big aspect, which helps us to preempt the future climate. So you have climate models that are there that help you to estimate what kind of climatic changes will happen in the future, and you can design preempting that now. So I think sustainability is enabled through technology, both at micro as well as macro level. And in this respect, let me just share my screen, to talk about a few. I know we are also pressed for time, but in general, I've just pulled up. So I'll just kind of go from the middle of the presentation because I'm sure we are pressed for time. So when we look at a sustainable or an energy efficient building, we look at multiple things. So it is not one thing that we look at. For example, to make an envelope energy efficient, we have to look at the passive design, which includes orientation, energy efficient envelope, window to wall area ratio. And when you do that, you look at daylight integration, you look at shading devices, and several other, low energy cooling and other things to be put in place. So a technology solution helps you to optimize all of it and take design decisions that are cost effective and will give you the desired, output in terms of the, say, the energy consumption that you are probably seeking from the project, or, moving towards a net zero solution. And since today we are talking about net zero, I would like to say that, we should explore first the passive options and the technology options that help us to achieve energy efficiency, and then move towards net zero through application of renewable energy technology. And this is again enabled through different processes. And we operate the rating system called LEED that helps us to kind of optimize these solutions and leverage technology heavily to arrive at net zero solutions. Quickly, again, when you talk about different scales, at an urban scale, there are so many things that you can address, which you may not want to address at the building level. For example, we know this phenomenon of urban heat island, which is due to extreme urbanization that happens. And we have also done a lot of research studies to show that how urban temperatures are increasing, and hence there is an increase in, say, energy loads in the buildings. And you can also use large urban scale solutions. For example, this is an urban scale solution where you use urban heat island mitigation strategies in terms of, urban agriculture that not only provides food security, but also helps you to, arrive at lower urban temperature that helps you in reducing the air conditioning load of a building. Again, this is possible to estimate these through use of different tools and techniques. We know the city of New York has a very large cool roof program, and this is one of the example of a certified building where a green roof not only provides the desired, moderation of temperature below, but also gives a very nice open space for people to interact and, kind of take advantage of. Then technology also helps us to kind of do cross-cutting issues. For example, as soon as I talk about green areas, the obvious question that comes is, where does the water come from? And there are many places that are water-starved. So this energy and water nexus also can be facilitated through different tools and techniques and technology. Say this is one of the cities that is certified to LEED, which is Albuquerque, where the green spaces have been done, but using, kind of water resistant native species so that you do not use too much of water. And again, now coming to specifically, again, as I mentioned that when we are talking about building, passive architecture plays a very, very major role. And we know that in India, we have 5 different kinds of climate zones, and we should design for that climate so that we do not, overuse air conditioning or other, energy consuming guzzlers before we adequately leverage passive technology. And for that, we use different, modeling and simulation techniques to arrive at optimum design solutions. And how do you do that? Again, through different, say, simulation software and tools, you can actually find out how much the building will consume before it is constructed. So what would be the best orientation? Example, suppose you rotate the building in the simulation plan, and you will be able to find that how much the cooling load of that building will come down. If you add reduce or increase the window areas, you will be able to estimate how much the energy savings will happen. And then also when you do an window to wall area optimization, you do not lose sight of, say, things like daylight optimization. So there are then Simultaneously, you also look at issues of thermal and visual comfort. So if you are looking at integrated solution, leveraging technology is very, very important. And then final outcome are buildings that are energy efficient. So, and we have found that through this technology adoption, you can actually kind of reduce from the base condition up to 50 to 60% of the energy, which is otherwise not physically possible to reduce if you are just doing these things manually. And we have, kind of enabled through LEED certification, several such projects. This one is a net zero building, which is in Japan, which has heavily, leveraged passive techniques, daylight integration, as well as other techniques like geothermal, etc., before adopting renewable energy techniques to arrive at net zero solutions. Quickly, let me move to one very important part that I want to talk about, is that when we are looking at net zero solution, let me just take 2 minutes to explain that how important it is, not only technology, but people who occupy this building to take suitable actions that finally we are achieving net zero. For example, this building is a net zero building in the United States, and it's a very small building. And we went inside and we asked the people that how is it that you are able to maintain it as a net zero? Let me stress on the word maintain. You can design it at net zero, but you have to maintain it at net zero. And one of the important things which they mention is occupant behavior, that people inside the building, which is designed as net zero or energy efficient, they have to be equally responsible to maintain it at net zero. Now, switching places, this is one of the first net zero building in India, which is the headquarters of the Ministry of Environment and Forest. Very well designed and net zero design. But unfortunately, I have walked the spaces inside the building and I have found that the occupants inside are not aware that it is designed as net zero. As a result of that, they have kind of bypassed many of the technology options and not retained the energy efficiency features that were embedded initially in the design. So I just want to conclude by saying that, it's very, very important for us to kind of look at different streams, how we arrive at net zero, be it embodied energy, be it operational energy. But finally, it is very, very crucial for us to have people who are inside the building to be equally responsible to be net zero and energy efficient. I'll take a pause here and then, I'm happy to answer any other question that you may have.
Thank you, Millie. I think the second question that will, help many of our architects and civil engineers to understand that how rating and certification steer project towards sustainability and mainstreaming.
So I think, when you go through a rating system, you put everything together through a framework. As we know that what you can measure, you can manage. If you're not able to measure things and if you're not able to quantify, you do not know how green it is. So sustainability framework or certification programs gives you that list of parameters which allow your building or urban scale project to follow. And then you can say whether you are good, bad, or, you are better than the best. So I think that is a big thing that sustainability, certification programs help you to achieve.
I would request my audiences that if they want to ask something from the vast experience of Millie ma'am, then kindly go ahead.
Millie, if you want to address some of the questions in the Q&A, you can do that.
Maybe I have one very important question, Millie. That
Yeah.
is what is your take on energy efficient buildings? And which are the low hanging fruits which can be, taken advantage by the people who are, building the project at a shoestring budget?
I think, use of, so what I mentioned, that use of bioclimatic architectural techniques, passive techniques, and local materials and local kind of, use of local technologies help you to reduce not only the energy operationally, but also the embodied carbon, which I mentioned of. So that is very, very important for us to harness. So there's a question, which says what sustainable approach should we adopt for infrastructure projects with horizontal development for reduced carbon footprints with respect to Indian context? Yeah, I mean, of course, when you say horizontal development, you should have that kind of space. I mean, there are a lot of debate around horizontal versus vertical. Both have their own, pros and cons. But I also think that there is a very important nexus between transportation energy, which is associated with a lot of urban sprawl, that as soon as you spread it, you will spend more energy in commuting and, accessing spaces. That is very, very critical. And as far as infrastructure projects are concerned, an integrated land use planning that places that, helps the people who are going to occupy or use the infrastructure to have a very good, work plus life coordination balance, as well as commute should be minimized. So I think for infrastructure, and particularly for horizontal development, this mixed land uses and leveraging transport and building integration, as well as things like, green infrastructure in terms of stormwater management, urban heat island reduction. These are very, very critical, that I would say. How much, there's another question which says, how much has the existing glass facade systems contributed to heat environment, due to which HVAC requirements, increase? Yes, I mean, I would say, glass facades do have an immense amount of responsibility for urban heat island mitigation, because as soon as you, stop the use, if you use a high performance glass, and if you're not allowing the heat to percolate inside, it gets also reflected back to the urban environment. So usage of glass facades should be, optimized, and it should be also properly externally shaded, so that we do not allow the glass to attract too much of, direct solar radiation. That's one thing. And also glass facades are a very, very, crucial part, not only to enhance urban heat island, but also on the, the bird life. I mean, there is a lot of incidents of bird hits on the glass facades, which has a very, very important, aspect on the flora, the fauna of the land around us. That's also a very important part. So glass facade optimization should be done, to address environmental issues. There are many other questions, but we are pressed for time. So I don't know. I mean, Plaza organizers, how do you want to address it?
Thank you, Millie. That was very nice. So proceeding to the next part of our presentation. So there is, sorry, when I press F5, it goes back to the first slide. So another technology and or material that really requires a deep look is graphene. But somehow graphene is form of carbon with a molecular bond length of only 0.142 nanometer. So if we stack several layers of it on top of each other, we can turn it into graphite. It is a very strong material. It can be leveraged greatly for lowering electricity cost. And if we add it to concrete, it can, bring down the emissions of concrete. However, there's a lot of gap while bringing this material from lab to ground actually. So electrochemical exfoliation is one of the methods which is being looked into to create large quantities of graphene. So here we have Mr. Sunil Malik, who is a part of original Revit team and joined Autodesk when Revit Technology Corporation was acquired in 2002. He has a large variety of business development, sales development, strategy, and technical position at Autodesk and Revit. So Mr. Sunil represents Autodesk at different architecture, engineering, and construction industry forums. He has been involved in evangelizing BIM across Asia Pacific markets since 2001 and has worked with various government agencies driving BIM mandate as well as with various large private organizations. He has been a key player and spokesperson for delivering smart cities and sustainable vision for Autodesk. So I think we would like to pass on the screen or the mic to Mr. Sunil so that he can share his experience in this direction, especially with respect to Autodesk.
Not able to hear you, Sunil. Audio challenge. Not yet. Not yet.
So Millie ma'am had to leave because of time constraint, but we'll continue with our other panelists and Q&A session. Little less, sir. No, it's very low actually.
Sunil, it's very low volume. Not legible. Audible. Not yet.
So, Chakri, can you hear me now?
Yeah, now yes, absolutely loud and
Okay, sorry about this. Okay, where are we? Now, are you able to see me?
Yes, sir.
Yeah, thanks. Thank you. I think a great presentation by Greta. Great to know that our stations are going to be redesigned and we'll be able to travel some of the good stations that's going to come up. Millie, thank you for this presentation. It was great. As said, I work for Autodesk. Of course, you are using a lot of our tools, but we also as a company, from an operating perspective, we are operating sustainably on a daily basis, right? So whatever we do in terms of actually designing more efficient cloud infrastructure and also looking at addressing our environmental impact of our facilities like offices and other things, we continuously try to improve that. We actually try to understand how it is performing. Our facilities, most of our offices are LEED certified. That's something that we have done over time. We also kind of make sure our collaborators, our suppliers, our business partners actually embrace sustainable practices along with us. Some of the area where I would say we have achieved net zero carbon emission across our businesses, for second year in a row. And we have purchased 100% renewable energy to cover our facilities and cloud services, events, and people working from office. That's something that we have done along with what we do in terms of design and designing software for engineers and architects who are designing and making things. Particularly in the field of architecture, of course, earlier when people have been working on two-dimensional environment, basically using CAD, Line, Arc, and Circle, there is very little data that actually you can use, and the whole process of sustainable or LEED certification process or other certification process that exist in other different countries was very much a manual process. Of course, we went into BIM with Revit, and today the buildings or infrastructure designed using BIM methodology actually gives you all the data that is required for understanding the sustainability of a building to a large extent. Of course, there is a lot of work that needs to be done in terms of embodied carbon. I just saw a question in the chat box about embodied carbon for material in India specifically. Is there something that is being done by the government or an agency? Yeah, whether USGBC is involved in that or IGBC is involved in that. How those measurements can be taken into our tools, and that you can click of a button, get the total carbon footprint impact of the facility that you are designing. That would be interesting. So there's a lot to be done, but in fact, BIM actually gives you a better perspective of actually understanding and basically impacting this whole idea of sustainability and net zero impact. Now, I'm an architect by practice, so I can tell you one thing, that design and analysis has to go hand in hand to achieve this whole idea. And that's exactly what we have done. We have actually included design tool and analysis tool together and given you ability to understand the design that you do on every step of the way, right? So whether it is right in the beginning to understand the orientation of the building or basic understanding of energy consumption using the tools that's within the AEC collection, like Insight, for example, understanding how renewable energies, if you put it into that facility, can impact the energy use of that building, that you can actually do it today. Of course, any optimization leads to actually saving of material, and that directly impacts sustainability in big way. So as you design using BIM and use analysis tool to actually reduce or optimize the design, you're actually saving steel, cement, and all the material that go into making the facility, whether it's a building or infrastructure. And that is actually sustainability, because you have reduced or you have used less material than you would have actually used in a normal
Mr.
basis.
Sunil, can I put across one question? That
Yeah, please.
as an architect or as a civil engineer, we sometimes want to understand that how much energy saving we have achieved in a building. So which are the softwares you can share with us, so that tomorrow when we are sitting on the drawing board, we know which software to target while taking out such calculations.
Right. So that's what exactly I was just I mentioned about building information modeling as an approach, and any tool that actually uses that particular philosophy actually supports sustainable outcome, right? So from an Autodesk perspective, I would say it's Revit that actually helps you design buildings, Civil 3D that helps you design infrastructure. There are other tools like Plant 3D, which are 3D solutions that actually help you design a plant. And also the building material that go into making building or anything else, actually we have manufacturing solutions that like Inventor or Fusion 360 that actually people use to make all of this. And they are also actually we have actually built in tools to help people optimize the design of any building material that go into the building optimally, right? So it is a whole process when you design a building. Most of the all the modern buildings today, almost 90% of the building is manufactured, for example. So how is the curtain walls manufactured? What is the impact of actually having a better manufacturing process? And how would that impact the carbon footprint of that building? Because that actually, after manufacturing the curtain wall, it goes into your building. So are we actually
there is, Mr. Sunil, there is another question as an architect which is coming to my mind, that in Metro that we are designing the buildings on Revit. Can those, drawings be used for the manufacturing purpose as well? So that we get a
yeah, there is a
product which is
process.
very,
If it's done using Revit, that those components or curtain walls or other building products can be sent to the manufacturers so that they have the basic shapes and stuff like that to actually look at how optimally they can actually manufacture it, rather than going to the drawing board with. If you give them a 2D drawing, they will have to start doing the 3D modeling itself and then make the product. So there is a working what do you call it working process between the building product and manufacturing product that helps you to achieve that, right? So that's how we can actually help the entire ecosystem. Not only that, actually, once you have manufactured, we have cloud solutions that help you to track that material that has been manufactured at a facility, to bring it back to the construction site and fixed to the location, right? So today, as you say, today buildings are not constructed, it's more manufactured. So how do you actually track sending the design to a manufacturer, then tracking that element when it gets manufactured, when it should be actually sent to the site, and when it is sent to the site, where it has to be unloaded, so that you don't incur double cost in terms of loading, unloading, for example, and when it is fitted and commissioned and all of that. So all those things actually can be done on a cloud solution, reducing a lot of time and effort for people, and thereby optimizing many things in terms of material and time. That leads to sustainability overall, right? Commissioning the building 2 or 3 months earlier, right? Or reducing material by 10, 15, 20%. That itself is going to be huge impact on sustainability. And not only that, actually, we can actually look at your water requirement, look at how gray water, black water is actually efficiently used. We just acquired technology like Innovise. People should actually look at that and see how that can help them in the water area. And the other thing is, of course, digital twin. We are actually already talking about digital twin in many ways. So what happens today is, as we just saw, buildings actually, if you spend, for example, $100 in the life cycle of a building, almost $20 to $25, $30 spent during design and construction. Rest $70 is actually spent during operations. And it's very important that we have good tools that can actually help you to manage and maintain that building over the years and reduce the operating cost of the building. And for that, we have tools, right? With the digital twin, which is actually a combination of BIM model with the digital data that you can collect from the living building, like IoT devices and all of that, understand how things are performing. Millie talked about designing a building that is LEED certified, whether it is platinum or gold, but then keeping it LEED certified all the time is more important, right? We have buildings which actually you design as a lead platinum building, but after 1 or 2 years, nobody maintains it as, then what is the use of making that building, right? So all these digital tools are actually going to help if you are actually going in the area of digital twins that will enable you to understand how buildings are performing, how this infrastructure is performing, helping you to keep that rating as you operate the building, right? So our tools actually, of course, we have been, Autodesk is known, everybody uses DWG, AutoCAD for that matter, right? But this are actually a line, arc, and circle. Line, arc, and circle has very limited information. So if you have to do LEED certification using line, arc, and circle, it is definitely a very, very manual process. You need to move to a BIM process to actually help you with better sustainable designing process. Getting data from the BIM model that will help you to populate and understand how your LEED certification can be achieved. Of course, we have to continue to work with government and agencies like USGBC and IGBCs so that we can have local information like embodied carbon, material carbon, or local impact of the material that can help you to do the carbon emission impact study also, right? So that's about it from me, and we have a good team here. So please reach out to us. Capricorn is our partner, of course, you know. So let us know how we can help you, and we'll be happy and glad to help. Thank you.
Thank you, Mr. Sunil. So we like to save the Q&A for the last. So we are now coming to our next speaker. I'll just put on F5 and I'll read the first again. I'll have to run through this again. Okay, it's not, so I'll just go through this. So aerogel is another material which helps us in getting cooling, like which is called non-electrical AC. So in this, it's like a bed in a room. The bed has 3 layers. Top is the aerogel, bottom is a mirror-like base, and in the center, there is hydrogen or water. With the help of this, we can achieve cooling with saving in electricity. The same material can also be used for increasing the shelf life of vegetables. Similarly, glass is a material which is now used in all buildings which are modern and so-called IT in the urban India or the world, but it lets in natural light and it loses a lot of energy. So that's a paradox which we have to deal with it. But then there is a transparent form of silica aerogel which is being produced, which with this advantage of light can also save energy. With this, I would like to introduce our next speaker, Mr. Chakresh Jain, who is he's the chairman of the board at Capricorn Technologies Private Limited. He did his architecture from IIT Kharagpur and started his AutoCAD training and consultancy just after graduation. He was initially focused on application of CAD in architectural design, but soon moved into partnership with Autodesk and expanded into software solution for entire building and infrastructure industry in the name of CAD Studio. Mr. Jain served as the founder and CEO of CAD Studio for over 25 years. In 2013, CAD Studio merged with 3 similar Autodesk partners and formed Capricorn Technologies, which is now a leading technology provider for building, infrastructure, manufacturing, media and entertainment, education, government, etc. Capricorn has been consistently recognized by industry and partners by various awards. A highly respected voice in AEC industry, Mr. Jain is actively engaged in various positions in IIT Kharagpur, Alumni Association, Pan IIT Association, and PhD Chambers of Commerce and Industry. So I would like to pass on the screen and the speaker to Mr. Chakresh, who will share his views with the audiences now.
So, in fact, after hearing all three luminaries, I'll not like to spend much time. First of all, I like to thank, but I like to share some of my experiences, maybe with the gray hairs, what we have seen as a journey. Because while I was studying architecture at a technology institute, that time, I remember like if I had to spend one entire night just reading the weather data charts and plotting a psychometric graph so that we could design a building and analyze what kind of weather conditions are there, how do we design. So today, of course, and from there, then when the best in terms, so that was in terms of analyzing, then in terms of designing, of course, climatology was our main understanding and whatever data we had that time. And then while designing, the best way we could think about sustainability apart from climatological information was whole brick design. Like, can we design a house? And I'm talking about almost early 80s. So where the way we were thinking about is whole brick design. So can we design houses at that time without cutting the brick? But today, after we see that the buildings have become a lot more complex, and of course, those kind of manual tools absolutely will not work. So we'll have to look at how do we really use the current tool and technology. So as Sunil said that in early 90s, I did try that in AutoCAD that can we bring in some sustainability analysis, etc. And the best thing I could do at that time in AutoCAD was, okay, we could find out certain sun orientation according to the location and time, etc. Of course, and then when Revit, Sunil was the one who introduced us to Revit in early maybe 2003 or so. And that's where we got fully excited that now, yes, we have a building model which will really serve that purpose. And slowly, and today when I'm using Revit, we have all the material information burnt into it, which really helps me to churn out my analysis much faster. And now, like, I remember my daughter when she was doing architecture, so she could, while designing the building, for every building, she could easily quickly do, okay, what kind of heating is required, what kind of, like what Millie was talking about, if I have to do the daylight analysis. So as a student, she could easily quickly run through those things and quickly work out whether she's put the appropriate window size, etc., kind of thing. So that's the tool which is available to the even everyone, even a studying student can do that. And that's the way we need to go. And that's what and of course, that's one aspect of the sustainability, and as what we've been hearing and what Millie also very nicely presented, that we need to study sustainability at each and every stage of a project. And the best example what Bretta has presented is the manifestation of whatever. So we might be talking about tools and techniques which are available, but the results have to be shown in some of the work, like what Bretta has presented, like how all those things have been manifested and converted into a project. And we'll really love to go and see some of the project which she has presented and experience them. And the challenge which I feel is there, like without the tools, it sometimes, if I was a architect who was only relying on maybe hand based manual analysis, there is a fear that I might have thought something, but I might get something else, which of course we had experience in a very basic design, that we as an architect are imagining things in our head and wish to make design in 2D, and what actually it might translate into a real form might be different. And same thing would happen for sustainability, as also been highlighted by Millie in her presentation. Like, the building was designed with certain ideas, but actually in the usage it didn't happen. And these tools would help us in a better and more accurate predictability, that this is exactly how we have imagined them, how we have designed them, and actually when they have been used in the real life, this is how they are also performing. Of course, I know there is no perfect results right now, but this perfection will come with every version. So I only like to thank Bretta, Millie, and Sunil for very thoughtful presentation, what they have done. I'll not like to take more time on that. So I'd like to hand over back to Madam Kalsi.
You're on mute.
With that, we come to another form of concrete, because concrete gives 21% global residential CO2. But there's another material which is saving a lot of energy, is hemp. Hemp is like a little controversial, but it has got a fantastic fibers, and it absorbs almost every hectare of a hemp 15 tons of CO2. So with that, now I request all the speakers to see their Q&A boxes and see if there are questions from the audiences and reply one by one. So I would like to request Bretta, if there are any questions or any audiences want to ask any questions, please go ahead.
Okay, then I start. I think somebody here asked how local people can get benefited from this project. So I assume you meant the station project, whether it is indirect or direct. So I think definitely this direct, because you are affected directly as a traveler. It will make your traveling a bit more hassle-free, right? If the departure and arrival is separated. I think this is what you meant. So I think, yeah, definitely it's direct. It's also indirect, because globally a new station building will also give more value to the city. So I think it's also indirect. If this project helps in preventing economic leakage, if I completely understand, I would say, I mean, this is a redevelopment. So Indian Railway, they are of course using the master plan, these buildings, plotting for saving and leasing, not to gain the money to gain the funding for the station. So yeah, you can say it is a diversion of fund, I guess, if this answers your questions, hopefully. Then I saw there was one about vertical gardens, which maybe is also for me. The question was, vertical garden, will it make building more green? I think definitely it makes it more, I mean, literally it makes it more green, but it also absorbs, it reduces CO2, it reduces the heat island, it reduces the temperature, it can also shade. It can have a lot of benefits. And besides all of this, it's also connecting people more with green again, connecting people more with nature, which I think is a very important benefit, especially in India. I feel more and more green in the cities is disappearing. So if people are living more surrounded by green, it connects people more with nature again. I think this is a very important aspect for residents and people, for their well-being. Shall I say? Yeah.
Any other questions from the audiences for Bretta?
Ma'am, there is one more direct question for ma'am.
Because I'm not able to, maybe Farhad, you ask the questions, because I haven't got the Q&A in my, webinar chat.
Yeah, I see there's one more. Now, what is the role of technology which you have leveraged to achieve the result for public spaces being reimagined? I think it's all about technology now. Now we need a technology to do sun shading analysis. We need to heat gain shadow analysis. Like earlier in presentation, it was shown, you can, depending on how you rotate the building, you will immediately know what is more beneficial. So, I mean, technology is crucial, and the role is very large. And I mean, there's a lot of ways, a lot of software, a lot of technology, of course, also in Revit. And the role is very, very important. I hope this answers your question.
Definitely it does. Farhad, can you ask the next question, because I can't see it in my chat box. The questions haven't come there.
Right, ma'am. Yes, ma'am. So actually, this is a question from me. Now, railway station design is a very unique design, because you cannot stop the trains. That is, so that's the most toughest part. So how did you tackle that?
Yeah, I mean, I was trying to explain it. Yeah, it is it is really a challenge, yeah. because the foundation of the columns have to be in situ. So this will have to be done column by column. But then afterwards, I mean, all will be prefabricated and installed. Prefabricated, it has to be prefabricated, otherwise it takes too long. And yeah, it comes all prefabricated and then build it up as fast as possible. In
And
the
Gwalior-
night, during the day, without interfering the train schedule. It is a challenge, yeah.
Yeah, and Gwalior is the main route. It's a very main, very critical route also.
Yeah.
You can't
I mean, there's a
divert
lot of
also.
stations which IRCC is redeveloping in India. It's everywhere the same challenge, yeah.
I think I like to add to that economic question now, and like what Beta just mentioned, there are 6,000 stations across the country, and government plan is to redevelop major of them. Of course, now government can't be spending money for all of them, and that's where they are trying to bring in some public-private partnership to be able to, and that's where they have to also kind of make some space. What was presented here for commercial usage of the station, which kind of in a way funds back the redevelopment of the station. So that's where
Yeah.
that economic model is being worked upon. I think it's something which has been worked for many years and it's getting fine-tuned by every project.
Yeah. I see there's one more for me. Are you also working on Kanpur Riverfront Development Project? When can we expect the same to go live? Kanpur Riverfront Development was a feasibility study. And this, yeah, it was a feasibility study for the government, but the government so far didn't approach us to, to do any more, to bring this to life, unfortunately, not yet. So I can't give you a date when it will be live, unfortunately.
I think with that, we are nearing the end of our session. So I would just like to, link the whole thing. Like Reta, she shared with us the industry experience, that how they are actually doing it on the ground. Millie, she explained to us that what is active and what is passive pooling, and why passive pooling should be our first choice, and then go to active pooling. As myself, I tried to look at the technologies and the materials that can, give us a link between passive and active pooling. Which are the materials that need to be relooked into, or the ones which are very interesting will be coming up in the future. And there are some materials which are at present, also showing very good behavior as far as building technology is concerned. Then Mr. Sunil shared that how at Autodesk they are trying to enrich us with the softwares which can help the architects achieve their objectives. And then Chakresh is industry experience and his architecture experience and experience of the younger generation. Still, I would like to put it together that there are building apps which are now putting all these technologies together, that instead of having 10 or 20 remotes in the house or having very deep technologies, we needn't use the remotes to control our house, and we can do it through an application on our mobile, and that's the place where the future is lying. Thank you, everyone.
Thank you.
Thank you, everyone. Thank you.
Thank you.